Okay, so we are talking about trig substitution. So instead of U substitution, we can use, why does that say that with an I? I'm going to have to fix that. Don't know why that's misspelled. Okay, we can use trig substitution. Okay, these three Pythagorean identities are what we're going to use for trig substitution. Okay, basically, if we have any of these radicals or any of those raised to like a 3 times power or whatever, we can use trig substitution and use these identities to get something to work out quite nicely. So, trig deals with triangles. We're going to be drawing some triangles when we do trig substitution. Okay. The identities that we used yesterday are still going to be important, like the power reducing. Okay. The work that we did yesterday was basically so that we can do these antiderivatives once we do the trig substitution. Okay. So these are going to be on the next slide. I want to tell you when we have each of these cases, which kind of substitution we are going to do. Okay? So, first one, if we have a squared minus u squared, then u can equal a sine of theta.
Which one is the, oh, it's A constant?
What?
Is A constant?
Yes. Why do we let u equal a sine theta? If u equals a sine theta, then when we do our substitution, u squared becomes a squared sine squared theta. Okay? Conveniently, we can factor out an a squared. And what is 1 minus sine squared? Cosine squared. So then we can reduce that down to just a cosine theta. That is why we choose u to be a sine theta. Okay? Our next substitution is if we have a squared plus u squared. I will say that sometimes we see a squared plus u squared even without a radical, and it's okay to use trig substitution. If we let u equal a tangent theta, then u squared becomes a squared tangent squared. Conveniently, we can factor out an a squared. And what is 1 plus tangent squared? Secant squared. So we can reduce this down to a secant theta. Then our last case is if we have u squared minus a squared. And in this case, we're going to let u equal a secant theta. If we let u equal a secant theta, then u squared is a squared secant squared. Okay. You can see where this is going. We can conveniently factor out an a squared. And what is secant squared minus 1? Okay, so this becomes a tangent theta. Now, what's different about trig substitution, okay, is instead of making a u substitution in terms of x, we are making an x substitution in terms of theta. Okay, so like last time we said let u equal this in terms of x. Now we're going to say, all right, let x equal something in terms of theta. And so our substitution is going to look a little bit different. Okay, so we're going to go through some problems, step by step, nice and slow. Piece it all together. Ready? It does look familiar.
Could you just use like regular tan?
It's not our tangent.
Sine.
It is arc sine. Yes, we know the answer to this. Okay? But I'm going to show you with a nice, simple integral what it is.
So we wouldn't use arc sine.
That is the answer. Okay, what is the answer? What is the answer that we should get?
So it's like arc sine x over 4.
Arc sine of x over 4.
Plus
Yes.
C, plus C.
Plus c. That is the answer. But I'm going to show you this problem with trig substitution since it's nice and simple and we know what the answer should be. Okay? If you have this problem, it should be a 2-second thing. It's arc sine, yes. Okay? I'm just going to show you with trig substitution. All right. So we have u squared minus, a squared minus x squared. What substitution do we want to make?
U equal 4 sine of x.
Well, what we're going to do is, whatever this is, that's what we're replacing. X is going to be 4 sine of theta. Which means dx is what? 4 cosine of theta d theta. Just like with u substitution, we needed to know what du is. Okay? With trig substitution, we need to know what dx is. Now, here, okay, we have 1 over the square root of 16 minus our new x is 4 sine theta. So now we have 4 sine theta squared. And it, instead of dx, well, now dx is 4 cosine theta d theta. Okay, so it's a different kind of it looks a little bit different than u substitution.
How do you get the value for x?
How do we get the value for x? So anytime we have the pattern of constant squared minus u squared, in this case it's x squared, then we let x be a sine theta. So since this is 4 squared, we took that 4, and then
So it's the U rule for all the three numbers?
yeah, so on the first slide we put u because it doesn't necessarily have to be x squared. It could be like 4x squared, and so that's why we put u there. Because if it's like 4x squared, then we would let 2x equal something. Does that make sense? Okay. All right, is everyone okay with this 4 cosine theta d theta? Okay. So then we're going to reorganize our integral. This is 16 sine squared, right? So I'm going to go ahead and factor out a 16, and left over is 1 minus sine squared. All right, what is 1 minus cosine squared? Oh, dang it. What's 1 minus sine squared? Cosine squared. And what's the square root of 16 cosine squared? It's 4 cosine theta, right?
So now you have 4 cosine, 1.
So our denominator simplified down to 4 cosine theta. And we're multiplying by 4 cosine theta. So what we really have is the integral of d theta, which is what? Theta. Was our original integral in terms of theta? No. So just like with u substitution, in u substitution we have to go back and replace the u's. In trig substitution we have to come back and replace the thetas. Okay? How do we do that? This is where our triangle comes in. Come back up to here and draw a right triangle. Oh, your triangles were drawn the other way on the other side, weren't they? If this is theta, do you agree that the sine ratio is x divided by 4? If we solve for sine up here in our substitution. So opposite over hypotenuse should be x over 4. This is just going back to geometry, right?
Yeah, just choose on one side.
And so this adjacent should be the square root of 16 minus x squared. How did I get that? Pythagorean theorem. Okay.
Maybe I got one of those. Actually,
This will be online too.
is there anything below that?
Okay. I'll save this as a PDF and put it online along with the video. Okay. So if I want to know what theta is, okay, we can do a couple different things this time. We know that the sine ratio is x over 4, and so like here, we can just solve for theta. Well, if we solve for theta, we have the inverse sine of x over 4. Which we all knew was going to be the answer anyway. Okay, but that's how we got it. This is not a problem that I think that you should do with trig substitution on a normal day. Okay? This was a nice way to introduce a problem. But the good news is if you do get stuck and you can't remember if it's arcsine or arctangent or arcsecant or cosecant or whatever else, you could fall back on trig substitution and just wait a couple minutes. Yes.
What was the last step you did to get the?
To inverse sine?
Yeah.
Well, since the sine of theta is x over 4, then the inverse sine of x over 4 equals theta.
Sine inverse of x equals. Sorry.
Does that make sense? Okay. We have x squared minus 4 under our radical. Are we substituting with sine, tangent, or secant? Secant. So since this is x squared, we're just going to let x equals. And since this is x squared minus 2 squared, we're going to let x equal 2 secant theta. So what is dx? So now we're going to rewrite our integral. X is 2 secant theta. So anywhere there's an x, we are going to write 2 secant theta. And dx is 2 secant theta tangent theta d theta. These are going to take up some room, by the way. Okay, so under our radical, 2 secant theta, the quantity squared is 4 secant theta, right? So we can factor out that 4, and left over is secant squared theta minus 1. Okay, are you okay if I go ahead and do this? Is that legal? Does that make our life a little easier? Yes. I don't. Not today. Okay. So now secant squared minus 1 is?
2 tangent squared. Wait.
Well, it is.
2 tangent.
Okay, so secant squared minus 1 is tangent squared. So the square root of 4 tangent squared is just 2 tangent.
And which tangent to 2 tangent squared when you multiply by tangent?
Okay. Do we have an antiderivative for tangent squared?
You do this on the left.
Could we do integration by parts? Like, to the integral of tangent theta?
No, we couldn't. Because no tangent, so we'd have to put in the derivative problem.
Well,
But you can derive infinitely if I'm not mistaken.
well, yeah, but you can still do integration by parts.
Or you can do that.
Maybe an quicker way instead of integration by parts. Tangent squared is equivalent to what?
Secant squared plus 1.
And we do have an antiderivative for secant squared. Right? We have an antiderivative for secant squared. What is the antiderivative for secant squared?
Tangent.
So this is 2 times the quantity tangent theta minus theta plus c.
How did you go from square root of 4 times secant squared theta minus 1 tangent theta?
So we know that this is secant squared minus 1 is tangent squared, right?
Yeah.
So this is the square root of 4 tangent squared. So this is 2 tangent theta, and so then I just multiplied it by the other tangent. Okay. Trying to save some room, but if you need to write that step in there, that's fine. Okay. So now, is this answer acceptable?
Yes.
Some terms of x.
It's not in terms of x. Okay. We need to change it back to x. So this is where our triangle is really going to come in handy because we have this tangent of theta that we need to switch. So let's come back up here and draw our triangle. So our secant ratio is x over 2. So secant is hypotenuse over adjacent. Therefore, the leg of our triangle is x square root of x squared minus 4. Okay, so we need to replace tangent theta. What is the ratio for tangent of theta? Here's theta. Tangent of theta equals opposite over adjacent, correct? So tangent of theta we can replace with opposite over adjacent. And then for theta, since we defined secant of theta to be x over 2, theta is arcsecant of x over 2.
You don't have a trig function, so just do tangent of r secant of x over 4.
It is better to write it as just a ratio, okay? Since we have a triangle, we can actually write that ratio, and that's better, especially for if this were like a definite, you know? Yes.
So find theta, you're just taking the inverse of whatever ratio you find at the top.
Yes. Yeah. Okay. And then if you have a trig function, you're just going to look at the ratio from the triangle. All right, we have time for one more. You should always look to see if root substitution is a possibility, because it's obviously the most efficient, okay? U substitution is not going to work here, and I see that we have that u squared plus a squared pattern in our radical, so that's going to be nice for trig substitution. do want to point out that this is still the pattern of u squared plus a squared, but 2x is being squared since we have 4x squared. Does that make sense? Okay. So first of all, if we have the pattern of u squared plus a squared, or a squared plus u squared, doesn't matter the order, what substitution do we use?
U equals a tangent theta.
Okay, a tangent theta. Okay, so since 2x is being squared, then we're going to let 2x equal a tangent theta. Josh, did you have a question or did you
No.
figure it out? Okay. All right, so if 2x equals 3 tangent theta, then x is 3 halves tangent theta, and dx is 3 halves secant squared theta d theta. Okay, so our tangent ratio is 2x over 3. There's our triangle. What?
You wouldn't ask about that.
You know what? This is going to turn out really pretty. We are going to replace x with 3 halves tangent theta. And then this is times the square root of 2x, the quantity squared is really 3 tangent theta squared plus 9. And then dx is 3 halves secant squared theta d theta. Three halves cancel. Yay. Okay, so we have secant squared theta d theta over tangent theta. Let's do some work with this radical here. 3 tangent theta is 9 tangent squared theta, right? So we're going to be able to factor out a 9, and we're going to be left over with tangent squared theta plus 1. Okay?
Here you have 9 times secant squared theta drives 3 secant theta. Tangent times 3 secant theta. 3 times tangent times secant theta.
Where are we talking about? Oh, this right here?
Yeah.
Okay, so tangent squared plus 1 is secant squared. So radical of 9 secant squared is going to be 3 secants. Okay. Okay, so we can reduce this down to secant over tangent. Do you agree?
Yes.
Okay. And that's really not a pretty fraction. We can't really integrate that, but we can reduce it using properties. If secant is 1 over cosine and we're dividing by tangent, sine over cosine,
And that's just 1 over sine or secant.
then this is just, it's just what?
secant theta.
Try again. You said 1 over sine.
Oh, cosecant.
Okay. Now, oh, I lost something there, didn't I?
A 3.
I lost that 3. We really have that 1/3 because we have that 3 right there. I forgot to write in my denominator. So we have that 1/3 out there. Okay, now cosecant theta. That's not an antiderivative that I expect you to have memorized, but that is one that we can look up in our book. Okay, so this would not be a problem. Like cosecant is probably not going to appear in an integral on like a quiz or test, but it could be in your homework. We can look that up on our book. The antiderivative,
Negative natural log
negative natural log
cosecant plus cotangent inside.
Okay, there's our antiderivative.
So
And since we already drew our triangle, this is a nice, easy substitution to get our answer in terms of x. So cosecant of theta, the cosecant ratio is hypotenuse over opposite. So hypotenuse over opposite. Plus our cotangent ratio is adjacent over opposite. There you have it. You cannot wait until Monday morning to look at this again. If you wait until Monday morning to look at this for a second time, you are going to have no idea what any of this means. Okay? Your homework is on your gold sheet. And I think we'll do those last 2 examples on Monday. Okay, homework's on your gold sheet. You got to do it. Have a wonderful weekend. Make good choices. Sean, we look forward to seeing you on Monday.